Hello again. My name is Andy Knight. You might know me as Pandy or the Automation Panda. Be sure to follow me on Twitter and read my blog at Automation Panda in all the places. I am super excited to be back here for Python Web Conference. I love this event. I love these jerseys. So let's dive in. Historically, I've been a software engineer in test, building high-scale solutions to testing problems. But currently, I am the principal developer advocate at Applitools, where I help folks get the most value out of their testing and automation. I'm also director of a program called Test Automation University. If you haven't heard about it, TAU is one of the best platforms online for learning about testing, automation, and software quality. And the best part is that all of our courses are free. Definitely check it out if you want to learn about things like how do I do testing with PyTest, or how can I do API testing with Python? All those courses are out there for free. So let's kick off this session with a fun activity. Do y'all remember those spot the difference challenges from when we were kids? I want to do one together. Take a look at these two pictures. They depict a cute underwater scene. How many differences do you spot? I'll give a few seconds for you to take a look. If I can give one away, if you look at the octopus, the smile. On the left, it's shut. On the right, the mouth is open. But see how many other differences you can spot here. All right, let's see how many there actually were. There are a total of 10 differences between these two pictures. So did you catch them all? I know when I've done this in presentations and workshops before, typically the group can find about 7 or 8 of them. Rarely do they find all 10. And rarely does one person find all 10, even if they're given, several minutes to stare at the picture. The comparison I'm showing you here on the screen was generated by the Applitools Images CLI. It zeroed in on all the differences in a matter of seconds. This is the power of what we call visual AI. Humans can't always catch everything, even when given lots of time. Visual AI is much faster and more accurate. Now, you might be wondering, why would I need AI to do this sort of visual comparison? Let me show you why. Here's what a basic pixel-to-pixel comparison looks like. The machine identifies everything between these two images as different. Why? Even though the two images look mostly the same to us as humans, they're actually slightly shifted and skewed. There's some fuzziness to the curves. They don't perfectly overlap or align. If we were to do this kind of basic comparison, it's basically useless to us. Instead, visual AI is trained to look at images like human eyes. It highlights meaningful differences despite shifts and skews. The term AI in visual AI simply refers to all the machine learning algorithms under the hood that perform these visual comparisons. Now, solving kids' problems is pretty cool, but visual AI is very useful for software testing, and namely for testing your web applications. Imagine that you're developing a web app or a mobile app. How do you know that your latest changes didn't skew a layout region, or nullify a title, or cause overlapping text? It's hard to find bugs when you must continuously grind out new features, especially when traditional automated testing, like something you do with PyTest and Selenium, typically misses these sorts of bugs. Think about the hundreds or even thousands of pages you might need to check in an application, and that you would have to check them continuously during development. I'll be honest, within my company, we actually have a Slack channel where we share all the UI blunders we find in public apps and sites. And some of the bugs that make it to production are pretty spectacular, like these we're showing here. Visuals are indispensable for UI and UX these days. Remember, we develop software for humans. We can't disregard visual aspects. Visual bugs make apps just as broken as backend bugs. They might not just look bad, they might actually break the functionality of your site. You risk your business and your reputation if you ignore them. Thankfully, visual AI enables you to make sure your apps look right and work right. So in today's session, we will look at what visual AI is, how it works, how we can test with it. You'll see how visual AI ultimately makes test automation easier. Let's walk through a friendly example together. We'll use a basic web app to make our example accessible to everyone. Here's the login page for a demo site that mimics a banking application. You can even try it yourself if you go to demo.applitools.com. The login page here has a main icon, user and password fields, and a sign-in button. Since this is a demo site, you can enter any username or password to log in. Just note that. If you just click sign in, it'll actually work. Pretend. Now, a simple test could be to make sure this page loads correctly. If any of these buttons or fields are missing, then we'd have a problem. We could automate this test using any tool or framework. For this presentation, I'm going to use Playwright, which is an up-and-coming open source test framework from Microsoft. Like Cypress, it has all the modern conveniences of automatic waiting, tracing, and reporting. But like Selenium, it has binding from multiple programming languages, including Python, which makes it one of my favorite. I'm going to use Python for my examples today, of course. Note you could use TypeScript, Java, C#. It's all good. Also, Playwright is super fast because it uses debug protocols for browser manipulation. If you've used Selenium before, you'll notice Playwright is much faster. If you want to learn more about Playwright, come chat with me after the talk. I am an official Playwright ambassador. If you're not familiar with Playwright, that's okay. The code should be straightforward enough that you can follow. Also, if you wanted examples with this in Selenium or Cypress, I can provide those as well. So let's dig into this code snippet here. This code snippet shows how to load the page and make sure the elements are visible. It calls page.goto with the website URL, so it brings the page up. And then it has a series of expect page locator to be visible calls. This is checking that all those elements, according to their CSS selectors, actually are visible on the page in the browser. If we run this script on this login page, it'll pass with no issues. But what if we change the page to this? Dun, dun, dun. Can y'all see the difference here? Let me go back and forth a few times. There are actually two differences on this updated page. Whoops. First of all, we have the logo or the icon is broken. And secondly, the sign in or login button has changed, both in text and color. So do you think our script will pass or fail if we run it against this page? What do you think? If we run that same code, let's take a look at it. If we run that same code against the updated or broken version of the page, will this script work? Fact of the matter is, as long as these CSS selectors can still find those elements, then the script will still pass, even if the page has visual bugs. Actually run this test against the second page, and it does indeed pass. Ooh, that's disconcerting. Let's look at a more extreme example. Here's the login page with all of its styling removed. It's still got the basic elements of the form, but it's very clearly broken. What's really shocking is that our script will still pass on this version of the page, even though it is screamingly bad. This represents a major test gap. Traditional test automation struggles to catch visual problems like this. It can't reasonably cover aspects of a page like size, color, or layout. Teams spend lots of time writing these test automation scripts, only to be disappointed when bugs like this slip through anyway. I know, I've been there. So let's replace those old school assertions with what we call a visual snapshot. This one-line call captures the whole page using the Applitools Eyes SDK for Playwright. It's that second line there, eyes check login page, with the target for the full window. We don't need to explicitly locate elements on the page to verify them. We implicitly just take a snapshot of everything. How this works is that the first time we run this test, Applitools will set the initial snapshot as the baseline against which to compare future snapshots. Then, the next time we run the test, it compares the checkpoint snapshot it captures to the baseline. The Eyes Test Manager, which is this web app portal display dashboard thingy, will highlight any differences in magenta, like we saw before with our octopus garden, so that we, as the humans, can determine if the changes are good or bad. In this visual comparison, we can see how Visual AI pinpointed the broken logo and the different login button. The broken logo is a problem, so we marked this test failure with the thumbs down. Let's take a look at the demo app's main page next. Remember, this is supposed to be kind of like a banking application. This page has lots of stuff on it. It's got a navigation bar at the top with search bar, notifications, and a profile button. It's got a sidebar with different kinds of accounts. It's got a financial overview with dollar amounts. It's got a table of recent transactions. And it's got a warning message at the top saying your nearest branch closes in however much time. Most web pages tend to be busy like this one. The login page is kind of a simple example, but in heftier applications, we're going to see lots of stuff going on. So the million-dollar question is, what should we check? I spent about 45 minutes writing a bunch of traditional assertions for this page. I know the text is a bit small on this slide, but I did have to check quite a few elements. In the top paragraph of the code, the assertions make sure that a bunch of logos and labels appear. That's all that expect page with this locator to be visible, or expect page get by text, which lets you select elements based on their text content. Again, to be visible, make sure it appears. The warning message at the top saying your nearest branch closes in needs a regular expression to parse the time. You can see that there. Why? Because that number of minutes until it closes could be different. We want to make sure that we're not hard coding values. Then if we want to check things like the menu element names or the transaction statuses, that's going to require a few steps of data transformation logic. So you can see how I scraped, let's say for the account types here, all the text contents for everything in that list. And then I made sure that all of those equaled some particular list. Or for the table statuses, I got all the text contents, and then I just made sure one by one that they were in an expected set. Not the hardest code to write, but still, it takes time, it takes effort. And let me tell you, when you're working with locators, you inevitably get them wrong the first time. So you try it, you run it, it fails. Why? You double check your page, you found out you did something wrong, and you repeat. That's how you develop test automation. The sad part is that even though I spent a lot of time working on this test, these assertions still didn't cover the whole page. They don't check the other columns in the transaction table. They don't touch the financial overview. They also don't account for visuals like layout or color. So ultimately, I did a lot of work for a little coverage. Ouch. Again, though, I can replace all those assertions with a one-line snapshot call. Excuse me. It's less work for a lot more coverage. As a developer myself, this type of simplification makes test automation so much faster to write, so much easier to write, and so much more enjoyable to write. It lets me focus on the behaviors more rather than the nitty-gritty details of what exactly is this element on the page. This line took me a minute to write. versus almost an hour for that previous slide of traditional assertions. However, there's more to test with the main page. The screenshots I showed before showed Chrome and a fairly standard browser viewport size. However, we could run this app in any desktop or mobile browser with any viewport size. Different browser types have ever so slightly different rendering engines. Most modern web apps also use responsive design to render the page differently based on viewport size. This makes pages even more susceptible to unexpected visual bugs. Similar screen size differences happen for mobile apps as well. Cross-browser and cross-device testing can create a combinatorial explosion of test configurations. Consider all the different browser types there are out there: Chrome, Edge, Firefox, Safari, and I hope you still don't need to test Internet Explorer. I hope that's gone, but I know in certain older organizations, they might still have to support them. Then there's also all the mobile devices for both iOS and Android. Tons of different screen sizes. You also have all the versions of each browser. Typically, you'll want to verify your app works on at least the latest 2 or 3. But again, depending on your requirements, you may need to go back version quite a bit. Then there's also all the screen sizes. Modern web apps have responsive designs that change based on those reports. So even if you pick your browser, you still got to do this. If our tests use visual snapshots for verifications, then we can use Applitools ultrafast grid to perform cross-browser testing for us. Instead of setting up environments ourselves, we can run our visual snapshots against any browser configuration we want in the cloud using the ultrafast grid. The way it works is pretty cool. Visual assertions capture snapshots, not screenshots. That distinction is important. A screenshot is merely a rasterized image of a page frozen at a moment in time. It's just a grid of pixels, basically. A snapshot, however, captures everything that makes that page come alive. It's HTML, it's CSS, and it's JavaScript. When Applitools Eyes captures a snapshot from one test, it can upload it to the ultrafast grid and be re-rendered on any browser configuration with any viewport size. Basically, it's test once, re-render many. Setting up this code is pretty straightforward in Python. In a setup routine, like a PyTest fixture, you can create a special runner, a batch for tracking the tests, and a configuration object. Then you can add any number of browser and mobile configurations to the configuration declaratively. This code snippet here adds 3 browsers, a phone, and a tablet, each with unique orientation or viewport. Now, we only need to run our tests one time locally or in our CI system to capture these snapshots, to capture the snapshots. The ultrafast grid will take those snapshots and re-render them across these 5 configurations, all in the cloud. So you don't need all that on your machine. Furthermore, this method takes a fraction of the time to complete as traditional cross-browser tests. Without visual re-rendering, you'd need to rerun tests in their entirety against different platforms for cross-browser coverage from start to finish. That multiplies your test execution time by the number of platforms to target. And we already know web tests are not that fast, even with Playwright. Visual snapshots take only a few seconds each to re-render and to compare. It's a pretty clever way to maximize coverage without lengthening time to results. So now that we know how visual AI can help make our testing easy, let's demo. I've got an example repository here. It's in github.com/applitools/example playwright Python UFG. So you can use this link. I also have a QR code if you just want to capture a quick snapshot of that. And I will show how to run tests in Python with Playwright and Applitools. Okay, so here is the example repo I was just showing. And I've got it open in Visual Studio Code. I like Visual Studio Code. I think it's awesome. I've got the Playwright extension for it, as well as the I have the Python extension as well as the Playwright extension. And so the project is fairly simple. You can check it out and run it on your own. The setup that we have, I put under tests, conf-test.py. And what we do is we import some stuff we need, like we've got PyTest, we've got the Applitools Playwright SDK, which you can do a pip install for, pip install eyes Playwright. And then we have the Playwright SDK. So in the conf-test.py, I have a bunch of fixtures that will help set up my tests as well as the Applitools eyes SDK. First thing we need to do is we need to get our Applitools API key. Now, in order to do the visual testing like I've shown, you will need to register an Applitools account, applitools.com/register. You can register the account for free. You get a limited number of checkpoints, or basically tests you get to run per month. So you can do this. It's completely free to start. When you create your account, you will get an API key. And so what we need to do is we need to set that API key for our tests so that Applitools knows when you upload your snapshots who they belong to. So don't share your API key. That should be secret. So keep it secret, keep it safe, just like any other secret. But here I've written a PyTest fixture. Session scope, why? Because for the entire session or the entire test suite run, I only need to read this in one time. I'm going to pass it in as an environment variable. Pretty standard practice for test automation. Alternatively, you could pass it in as a command line argument through PyTest. You can make a custom arg. I think from my experience, the environment variable is going to be a little bit easier to set up and a little more standard universally. So we'll get that. And now we have the API key. Next fixture we want to do is we want to make a test runner. This is what's going to run our snapshots in the ultrafast grid. So we create a visual grid runner object that comes from the Applitools SDK. And I'm going to set a test concurrency of 5, meaning I can run 5 checkpoints at a time in parallel in the grid. If you're on a free account, you will be limited to 1. Then I'm going to yield that so that tests can use it. And during test cleanup, it's going to print all of the results on the console. I have another fixture here. This is for the batch information. This gives the collection of tests you're going to run, the suite, a name as you upload it. So I'm just going to call it example, Playwright Python with the ultrafast grid. Now for the configuration, this is declaring all those browser configs you want to test. I create the configuration object, set the batch, set the API key, and then same browsers from that slide we saw earlier, the fixture returns it. Then my final fixture, and this is going to be per test, not per session. This is going to create the Applitools eyes object. This is what captures the visual snapshots. So whereas you can have the configuration and the runner for your test suite that are shared, every test needs its own Applitools eyes session. So it says this is a test case. It requires all those things we just got, the runner, the configuration, as well as the Playwright page, and then the PyTest request. So what we do is we create the eyes object, we set the configuration on the eyes object, we pass in the runner, so that it's all connected. Before the start of the test, we open our eyes that says, hey, I'm going to start capturing visual snapshots. We give it the Playwright page object so it knows what it's looking at. And then we can give it an app name and a test name. That's just so for logging and reporting. The test name, we're just going to grab the PyTest function name. That way we don't need to call open in every single test case. And I'm going to set a standard viewport size locally. We yield our eyes so that tests can use it. And then during cleanup, we're going to close the eyes saying we're done with the testing session. I've chosen to put all of this setup in PyTest fixtures because I think fixtures are super nifty for setup and cleanup. As you saw, they can handle both. You yield, and then you can also separate your concerns very nicely. because rather than have one giant setup method or function for everything, you can basically piece these out as different objects. And then you can decide, do I want to run it once for the entire suite, or do I want it per test? So if you're not familiar with PyTest fixtures, that's okay. Just remember setup cleanup. I recommend go to pytest.org/docs, and you can read all about how fixtures are the bee's knees. So that's a bit of setup, but remember, all these fixtures are things that if I had a large test suite of, let's say, 100, 1,000 tests, I'd only need to write these one time. So then when it comes to the test case, which is in the test acme bank.py module, the entire test code for my one test case that I showed fits within the screen. I don't even need to scroll. So all those fixtures make your test cases even more concise. So what does the test case look like in full? Well, I need the playwright page object. That's where I'm sending my interactions. And I need my Applitools eyes object. All the other stuff, the config, the batch, the runner, right? We don't need to pass that in directly. All we need is the eyes, because the eyes were set up with all that. So here's my 4-step test. Load the login page, page.goto. Verify the full login page window, eyes.check, boom. Handles all my assertions. Perform login, find the username field, fill it with username, find the password, fill it with password, click the login button. And then finally, check the main page. Again, eyes check window in full. Remember, testing is interaction plus verification, nothing more, nothing less. Interaction, verification. Interaction, verification. Where visual AI is really going to help you is with that verification side of things. Because rather than have to scroll all the way down the page with like 100 different assertions for every single element on your page, you can just say snapshot, and it's covered implicitly. So let's run this. To run this, you will need to set your API key as an environment variable. I've already done that. And to run it, it's just like running any other PyTest test. I've already done my install of my dependencies and all that. So python-m pytest, and I'm going to give it the tests directory. Now, another thing to note is with Playwright, everything runs headlessly. If you want to make it run in headed mode, you need to add the headed command line option. And all this comes from the Playwright PyTest plugin, which is an extra dependency. Very standard. If you go to playwright.dev/python, you'll find all the instructions. It's just an extra package, and it makes it so much nicer to use. So let's run this. So we can see the window come up. Boom, page is loaded. It's taking that visual snapshot now. It logged in. It's taking the second visual snapshot, and then it's going to close down. And right now, it's uploading those snapshots to Applitools Ultrafast Grid. So I'm going to come to my eyes test manager. Here we go. Once you get an account with Applitools, you'll be able to log in here, and I'm going to refresh. And we can see on the left, that's my batch, example playwright Python. And then these are all the test cases. So if we refresh, very fast, ultra fast, wow. So note, even though that I only ran one test case, you can even see just one passed here, right? And PyTest, let me pull this up a little bit. There's only one dot, meaning only one test ran locally. Even though I had only one test run locally, you can see there's 5 test results, each for those different browser and mobile configurations. Like this one is running on Safari, this one's Firefox, these are my devices, this is Chrome desktop. So if I open this up, you can see I have 2 snapshots that were captured. Cool, cool. I look in here. This is establishing the baseline for the login page. And then we're establishing the baseline for the main page. And if I open up different the snapshots here, we can see like here, this was on the desktop, whereas this one was on mobile. And you can see how it's narrower. If I open that up, that looks a lot different. That looks like a mobile platform. So one test generates multiple different things. Pretty cool. Awesome. And so if we see how long this took to run in the ultrafast grid, these 5 tests with 2 snapshots each, so essentially like 10 checks, took 18 seconds. Not bad, not bad. We can also see how all these results are new because this is establishing a new baseline. If I were to run this one more time, And I'm going to run it headless now since we've seen it run once. If we run it again, now it's actually going to do a visual comparison, right? At first, it's just, you got it the first time, there's nothing to compare to. Every subsequent time you run, like for example, you push a change, your CI system kicks off the pipeline, runs the unit tests, runs your integration test, your end-to-end test, right? It's going to be testing those changes. Therefore, the visual diff is now going to say, oh, well, let me see what it was like last time. If we come back to the dashboard, boom, boom, we can see we have the next batch running. Oh, very cool. It's already finished. Again, that one took 19 seconds. Wow. Okay. And now if we were to go into one of these, we can see, all right, now we have the baseline compared to the checkpoint. And because they were essentially the same page, right? We didn't make any changes. Applitools Visual AI says, nope, everything's the same. We're passing. We're good to go. So it automatically marks these results as passed. Now let's break it, right? Because happy path is cool, but it's not that interesting for testing. Remember that broken login page we saw? Let me make sure I get the address right here. Demo.applitools.com, index v2. Okay, that's right. This is the link for the broken page. Same demo.applitools.com/index_v2.html. I want to put that in the code. Okay, got it. Very nice. And let's rerun the test one more time and see what happens. Okay. Might take a moment for the batch to appear. There it is. So we'll let these tests run, give it another half a minute or so. And we should see some more interesting results. Ba-bum! There we go. We got the first one in. It's not passing anymore. What happened? Oh no, they're orange. They're unresolved. What? Wouldn't they be failed? Something to keep in mind with this type of visual testing technique is that visual AI is a change detector, right? It tells you exactly what was different on your page. Boom, boom. It is up to you as the human to determine if those changes are good or bad. Because in our case, we have that broken link. We know it's going to be bad. But it could be that you're, as a developer, you deliberately made a change to the page that is a good thing. Your tests would detect that and say, oh, well, that's different. You have to go in and review it to say, no, that's a good thing. And if it's a good change, when you give it a thumbs up, then that new image becomes the new baseline. So that future tests go against that. Now you might be thinking, hey, Andy, isn't that like a waste of time? Isn't that just unnecessary information? Not necessarily, because when you're developing a web application, you're using like, I don't know, Django and HTMX, or I'm actually using Fast API plus HTMX right now. It's the coolest thing. Ask me about that later. I'm so thrilled with HTMX. I'm an HTMX stan now. I can't help it. But anyway, let's say you're developing a web app and you make something on your view. What do? Do you just leave it in Python code and Jinja 2 templates and move on to the next thing? No, you run that thing and you bring it up in a browser and you look at it to make sure it's right. And how do you know it's right? You mentally compared it to what you had before. What is visual AI doing for you at scale with automation? You made a change, you submitted it or committed it. The visual AI is giving you the results to be like, here's what it was, here's what changed. Is this what you expected? That's the power of visual testing. So anyway, that's why these results are unresolved, because you as the human have not resolved if these are good or bad. So it's kind of like, warning, hey, come look at this. I detected a difference. Can you tell me if it's good or bad? So if we come in here, we can see, oh, so the main page was okay, but the login page was different. Oh, let's take a look at this. So if we zoom in a little bit, we can see what's different. They're highlighted in magenta, of course. If it's a big long page, you want to kind of pinpoint it, you can click this and say highlight differences, and boop, 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 boop. So really, it looks like there's 3 differences. Woo. So we can see the login logo is obviously different. We can see the sign in button is different. This remember me, that doesn't look too different. Sometimes what can happen is when you have differences due to shifting of elements, some elements that are essentially the same get shifted over and they're marked as different. We can ignore that though. Up in our view toolbar, we could say something like hide diffs caused by element displacement. And if we do that, we get much sharper results to our visual comparison. And we can see that remember me checkbox is not really different, it just shifted. This is another power of visual AI. A pixel to pixel diff can't do that kind of feature for you. But with visual AI, seeing things like human eyes, it knows like, oh, shoot, actually, that's the same. It's just a little moved. Okay, remove that from the comparison. So we've got 2 elements now here that are different. Sign in, login, maybe that's an okay change, but this broken image thing, that's definitely thumbs down. Now we could just put a thumbs down, throw it over the fence and say our job is done. But why not do a little bit of root cause analysis here? What I can do from the view, I can go to the view root cause analysis sidebar here, and I can click on the elements in question, and we can see exactly what is different in the HTML and CSS. So in this case, like what made my image break? Well, because it's a demo site, we deliberately injected a broken image PNG. Ta-da! We found it. But in the real world, you would see like, okay, well, maybe there's a different image link here, or maybe there's no image at all. Or like the styling here, right? The styling is a bit different from what was original. So this ultimately is the root cause of why you have this visual difference. And so rather than have to munch that yourself, you can get it directly from the viewer. Now, let's say, okay, cool, got it. This is definitely a bug. I want to report it as a bug. I want to make sure I communicate this out. What we can do is we can actually add an annotation to our snapshot. We can add a bug region. So I'm going to, up here in annotations, I click this, I'm going to stretch over and highlight this and be like, hey, logo image is broken. I'm going to create this. And I'm going to put in what I got from root cause analysis. That's what's different. You can put any notes you want. It's cool. And then ultimately, I'm going to mark this test as failed. Now we have 5 different snapshots that are affected. Are you going to have to go to every single one and mark it as failed? Let's take a look here. So I only marked one as failed, but behind the scenes, the automatic maintenance that Applitools does identified that, hey, this one is similar to this one, and it automatically marked that as failed too. So you might be worried about the burden of results you have to triage with visual testing techniques. Applitools does make it a little bit simpler because it's using that visual AI to forward and go through to look at others. It's not perfect. It doesn't get everything. For example, those were the smaller ones. Here, yeah, we can see that's also failed. Boom. Automatic maintenance is going. Let's see what it does. Oh, it marked one more. So, all right. So my triage has helped. Anytime you make changes like that, you save it. And now the really nifty thing is if I were to run these failed tests again, Applitools would notice that, hey, this is the same failing snapshot again. It will automatically mark that test as failed. Or if you fix it and it's back to the original working baseline, Applitools will automatically pass it. So there's that maintenance of your results built in. Now, there's a lot of other stuff I can show with visual AI and testing techniques with this. If you've got multiple branches that you're working on at the same time, we can handle that. If you're doing different A/B versions of your site for A/B testing, again, branch baselines can handle that. You can filter your results through the ISS, basically any sort of test maintenance you could imagine. The main thing I want you all to get, though, is the idea of visual testing techniques in your test automation, how it makes it easier and faster. That's the main idea here. So let's wrap it up. Again, if you wanted to see that code, you got it on GitHub right here, QR code, or Applitools/example playwright Python UFG. So thank you all so much for listening to my talk today. It's been a pleasure to be here again at Python Web Conference. I love this event. I love 6 Feet Up. I love this jersey. I also love HTMX. We talked about that before. So here, this slide is the money shot. One place got the 5 key advantages of visual AI and what it can do for your testing. Number 1, visual snapshots cover everything on the page. Number 2, visual AI focuses on meaningful changes to avoid noise in your results. Number 3, visual snapshots enable lightning fast cross-platform testing for both desktop and mobile. Number 4, visual assertions provide more coverage for less code and less maintenance. And number 5, anyone can use visual AI and review its results, right? It's obvious. It shows you on the screen. This is what's different. So you could even show this to like product owners or BAs, like people who aren't necessarily hands-on code. So I've got the example repo again down here. I also have an article I've written about that. So again, thank you so much. I hope you've learned a lot. I hope this has expanded your mind and you can think about new ways to pursue testing excellence.